Be right back. Oh, we're back. It's been a hot minute, guys. Let me go ahead and post this up. Just let people know I'm streaming if they want to come in and watch the mad stumblings of a guy trying to learn. It has been a hot minute. Still not everything completely unpacked, but I'm getting there. Moving is amazing. Awesome, some would say. Let's see. There it is. Cool deal. All right. Let us do this. Okay. Sweet. What's up, folks? Okay. Yeah, so last time we had gone through the A plus, A star plus, A star pathfinding, and where I ended up was here. After after aligning everything, making sure these fit. I went and added a little background to it. That way my squares don't look so plain. Then we also went in and added another debug visual grid over this. So when you right click, so they make a wall. When you right click, it blocks that path off or that node off. So you can actually go around it. Aha, yeah. So that was pretty cool. This is going to come in handy a lot. Namely for, I still haven't added player movement to the camera yet, but I'll get there. But yeah, one of the things I'm going to do is I'm going to, I didn't handle for that exception. Damn. Do that here. Although this shouldn't get called immediately. Where's that get called from? We'll live for now. This come in handy. Say you have like a platform, right? In our case, it'll be like an RPG of some sort. So you're gonna have like, I don't know, raised platform. And so you have a mob that spawns down here. You're standing up here. You're gonna need to figure out a way for it to be able to navigate to you, essentially, or say has to jump over something like that. It's basic pathfinding, but I mean, get that down packed, and that's a huge chunk of the game, right? So, yeah, call this one good. And so that being said, what we're going to do now is we're going to move on to the next one, which is the awesome grid building system. Now, when I was looking at this earlier, essentially it looks like he layers on top of a lot of things he's done in the past. So what we're going to have to do is I'll watch through it, make comments. Feel free to watch along, go through the video. But he makes a lot of comments on, oh, you can do this by looking at my old video. There, I describe how to do that. If it looks like we're going to need to do that, then chances are I'm going to go ahead and jump to those videos out of this one. And we'll see if we can get those knocked out. But until then, I'm going to go ahead and boot up this video and let's watch it through.
Hello and welcome, I'm your Code Monkey. In this video, let's learn how to make an awesome grid building system. So we have a grid in our world and we want to build something on it. And that something can obviously be anything you want to build on a grid. So for example, you can use it to place enemy positions in an RPG, or maybe resource nodes in a survival game, place plots in a farming game, or maybe some traps in an action game. This is an extremely versatile, very useful system. You can definitely look forward to me making some more complex tutorials using this system as a base. For example, I'm currently building a factory automation game that uses this system as the underlying base. So if you're watching this in the future, check the playlist linked in the description where I'll be adding any systems I build on top of this one. The example that I will show here is on placing buildings kind of like a city builder. And just for fun, I won't be making this in 3D, but it works pretty much exactly the same in 2D as well. The underlying grid class supports both 2D and 3D. I will showcase the working 2D version in the end. Now, I've already made a building system once before. That one is a freeform building system. It works based on physics, so as long as there's no collision, the building can be placed anywhere. Go watch that video if you want to see how that one works. And that method is also what I use in my Complete Builder Defender course. So that's a great freeform system, but here let's go with a more rigid grid-based approach. And for that, obviously the very first thing that we need is a grid. Like I always say, you should always reuse as much code as possible, so as you might expect, I'm going to be using the grid system that we made in a previous video. It's quite amazing how versatile this grid class is. I've used it in dozens of videos by now and it's extremely useful. If you're new here, go watch the video link in the description to see how this class was made completely from scratch. So let's begin making our system. Let's make a new empty game object, name it the grid building system, and let's make our script. So a new C# script for the grid building system. On the object, let's reset transform, keep things nice and clean on 0, 0, and just drag the script. Okay. Now here, first things first, let's start off by making our grid. So let's make a private void awake, and on awake, let's instantiate the grid. Alright, so here is the basic instantiation code. Again, go watch the grid video if you're not familiar with all of this. We're just defining a grid width, a grid height, and a certain cell size. Then we're instantiating the grid, creating a new one, passing in the width, height, cell size, the origin, and then a constructor for each grid object. And for that one, it's right here, the grid object, which stores a reference to the grid, the X, and the Z. Like I said, go watch the grid video to see how all of this was made. Everything here was created completely from scratch in a separate video. So what this does is it creates a grid, and on each grid position, it contains a grid object. So let's visualize this to see what it looks like. For the visualization, let's go inside the grid class, and in here I've got a very simple show debug boolean. So if I set this to true, it will automatically draw some lines and create some world text. So on the grid object, let's also just do a public override the toString, and here let's return just the position. So X, then a comma, and a Z. Okay, so we should be able to visually see the grid. Let's see. And yep, right away we can see the grid positions, and if we enable gizmos, we can now see each area for each grid position. So as we can see over here, we've got 0, 0, then 1, 0, 2, 0, 3, 0, and so on. And here it is, all of them going all the way up to 9, 9. All right, so here is our fully working grid in 3D space. Now on each of these positions, we have an instance of this grid object. So on each of these grid objects, we can store any data we want. For example, saying that there's a building on this grid position. So to begin, let's just instantiate a building. On our grid building system, let's make a simple private void update. On update, let's listen to the mouse button down. So when the left mouse button is down, let's spawn a building. And for the building, let's go up here, let's add a serialized field, make it just a transform for the test transform. So now to drag the reference, over here in my project files, I already prepared a bunch of visuals. So for example, this building right here. So here in the prefab, we have the building. Then down here we have two objects. So one of them is the area, which as you can see the scale is at 1010, which is the exact same scale that we set for the cell size of each grid position. And very important, I've got the anchor, which is the pivot. So the pivot on the visual is right in there. So it's not down the center, it's on the lower left corner, which is going to match perfectly with our grid. I made a video on how to move the pivot if you're not familiar, but essentially you just move the children, and that way now the building, the pivot is right in there. Oh, and also the buildings that I'm using here are from a really nice asset pack. There's a link in the description if you want to pick it up. So just drag the reference of the building on there, okay? Now here we've got our transform, so we're going to go, when we press the left mouse button, we
Alright, so
have two objects. So one of them is the area, which as you can see the scale is at 1010, which is the exact same scale that we set for the cell size of each grid position. And very important, I've got the anchor, which is the pivot. So the pivot on the visual is right in there. So it's not down the center, it's on the lower left corner, which is going to match perfectly with our grid. I made a video on how to move the pivot if you're not familiar, but essentially you just move the children, and that way now the building, the pivot is right in there. Oh.
Interesting. I mean, technically. Child 2, child 1. Oh, I guess I didn't need to go all out. Remove this. Just add those here. So you got what? I think I could figure this out. So where's my anchor on this thing?
Oh, and also the
Yeah, let's go back and watch that. Let's see. Oh, he uses this. That's pretty neat. He gave a link for the asset pack that's being used. Ooh, it is not free. Therefore, we will not get it. All right, we're jumping over onto the pivot
figure out
video.
how to set the transform pivot to a game object. Let's begin. So here we are in an empty scene. Now, if you're new to Unity, one of the first things you'll need to
Back
learn
in
is how to make
2019,
a
he
help.
made this.
So if you want to make it in the world rather than in the UI, you will learn the way to display a sprite, which is first you create an empty game object, and then you add the sprite renderer component. Just like that, drag the bar sprite. And just like that, you have something that looks like a health bar. However, now if you try to scale it, you will notice that it scales from the middle. So in here you would go into the scale and modify the X, and yep, there you go, it is scaling from the middle. So by trying to make it smaller, it will actually scale on both ends. Now a health bar is usually supposed to scale from right to left, so this will not work for what we want to do. And now in here, before we go further, I should point out that if you're using sprites, you can simply go into the health bar import settings, and here you can set the sprite pivot. So you could set it, instead of being in the center, set it on the left side, click apply. And as you can see, now the origin of the game object, which is right in there, is on the left, just like we said on the texture, and we can now scale this normally. So we can now move the X and it works just like that. However, for now, let's ignore this ability for the purposes of understanding how Unity deals with transforms between parents and children and the difference between local space and world space. If you understand how transforms work, you'll be more capable of creating anything you want. For example, if you're using the white pixel trick that I normally use, you can't modify the texture pivot without a lot of hassle, so it pays to know how transformations work. So let's reset this back to center and keep looking at how transforms work. So essentially, a game object will always be transformed from its center. It doesn't matter what sprite it has or what box element is attached to it. The transformations are always done from the origin of that game object. So in order to essentially change the pivot, you need to be tricky with how you position your child game objects. So here in the help bar example, we want it to go from right to left as it shrinks. Now in order to do that, we can make this game object a child of another game object. So let's set the scale back to 1. Now let's create another empty game object. Let's place it on 0, 0, same thing for this one. Let's call this our health bar, and let's call this our health bar sprite. And then we make this one a child of our container game object. Right here, the values that you see are the local values. So if I put the parent, let's say on 10, 0, and we check out the inspector for the child, it does say 0, 0. Again, this is the local position for this game object. Same thing with the scale and all the others. So if I scale by 2, check out that one, and it still says just 1. So let's reset this back to 0, back to 1. And now if we modify the scale of the parent, we still have exactly the same thing happening. However, by moving the child, we can essentially change the pivot of the transformations when we transform the parent. So in order to achieve our desired effect of scaling from right to left, let's shift the inner bar sprite to the right. Now in here, how much you shift will depend on the scale. In this case, let's see the texture. The texture is 512 of width, and we're using 512 as pixels per unit. So that means the actual size on our game engine is 1 unit. So if the sprite is 1 unit and we shift it by 0.5, you can see that the pivot on the parent is exactly on the left side. And now if we transform the parent, let's go in here and modify the scale.x, and you can see that it does indeed scale from right to left. So we position our inner sprite in such a way that we modify the transform pivot when we modify our parent. Now in order to make a completed health bar, let's add a background sprite behind it.
I see. So I think my logic here is a little backwards. So we'll say this is the parent. And in here, we want to create a square. Let's go back a bit on what he was saying.
512 of width, and we're using 512 as pixels per unit.
Okay, just fudging around. Yes, apparently that screwed with everything. Whatever. This out of the way a second. All right, there we go. All right, cool. So he was just saying you move this over. I don't know. There. 0.5. Take this. Muck with the scale. Ah, okay. Okay. So that's all it is then. Sweet. That way, if you do the rotation, well, I guess the rotation on the X won't work. It would be on the Y. No? Z? Oh. Because Z is pointing, yeah, towards the screen or away from the screen. Gotcha. So the Z would have to pivot and you go, wee. Okay. Got it. Makes sense. All right, let's see here. Let's just clear this up and then continue back on the other one. Awesome grid. All right, cool.
Familiar, but essentially you just move the children, and that way now the building, the pivot is right in there. Oh, and also the buildings that I'm using here are from a really nice asset pack. There's a link in the description if you want to pick it up. So just drag the reference of the building on there, okay? Now here we've got our transform, so we're going to go, when we press the left mouse button, we're going to instantiate our test building, and then we're going to need a position and rotation. So for the position, I have a class to get me the mouse position in 3D space. So here it is, get the mouse over position, and what it does is a camera main, screen point, using the mouse position, and so on. So just getting the mouse position in a 3D world. So I just use that, put it in there, and with no rotation, so quaternion identity. So now as we click, we should be able to place down a building. Let's see. Okay, so here I am, and if I click, yep, there you go, it places down the building exactly on the mouse position. Alright, so far so good. However, the building is meant to place on the grid position and not on a regular.
Alright, let's see if we can get this.
Back, the pivot is right in there. Oh, if you're not, the anchor. In my project files already prepared a bunch of.
Alright, so let's get that down. So the first thing he does is he has a grid. Go back some.
Again, let's just
I did say I'd watch the video all the way through, didn't I? I'm so bad at this. Let's continue watching the video. Sorry.
Just do a grid in order to get the worm position, pass in these X and this Z, and this is the one that we're going to use here. Okay, so now it should be placed exactly on the correct grid position. So if I put it, let's say, right on the middle there, and I click, and yep, there you go, placed perfectly exactly on that grid position. So wherever I put it, it always snaps to the exact perfect position.
That's cool.
All right, awesome. So we have our grid, and we can place buildings on it. Now the issue, of course, is that I can place multiple buildings on top of one another. That is not intended. So that means that on each grid object, we need to store some data based on what building is already on there. So over here on the grid object, let's add another field. Let's name it a transform for the transform that is placed on top of this grid object. Then just some simple function to set it and get it. So when to set transform and when to clear it, which we're going to use later when we implement demolish. And let's also modify the toString to also include what transform is on there. So just make a new line and then the transform. And also the way that the debug visual is set up, the grid class needs to know when something changes. So just here, just trigger a grid object change, pass in this one and this one. Just so that the grid knows when something changes and then it updates the text. Okay, so we have our transform. And now let's make a simple function to test if we can build. So just a public returns a boolean, let's call it can build. And here it's very simple, we just return if the transform is null. So if transform is null, then we can build. If it is not null, then we cannot build. Okay, so now here on our update, we get the grid position. All right, now before we instantiate, let's go into the grid and we get the grid object on this X and this Z. So this returns our grid object. And now here we go into the grid object and we ask if we can build. And if so, then we are going to build it. And after we instantiate, let's do a build transform to grab our reference. Then we go into the grid object and we set the transform to this one. So we build and we set it, and if not, then that means that we cannot build. So for this, let's spawn a fun pop-up message. So here I'm using this function from the utilities, which you can grab for free from unitycodemonkey.com, or of course you can make your own warning message, like for example the tooltip that I covered previously. Just a bit of fun, just telling the player why it cannot build. Okay, so with this, let's test. Okay, so here I am, and if I click, yep, there you go, it gets placed, and over there on the text we can indeed see that it worked. So we can see that this grid position is now filled with a building clone, alright. And now if I click again, nope, there you go, now I see the nice pop-up saying that I cannot build because that one is already occupied. Alright, awesome. So with this, we already have a really good start. We can place down buildings anywhere you want, and we make sure that we only place them on clear ground. So this is working, but so far it's only working with this shape. However, in most games, when you have a building system, you don't usually have just a single one-by-one shape. Some things you want to place will occupy more than one grid position. So let's handle that.
Jeez.
And by the way, if you find the video helpful,
I always get tired watching
like
videos.
Button. It really helps out the channel. For that, the first thing that you need is some way of defining each building type. And for that, over here, I've got some building type scriptable objects. I covered scriptable objects in detail in another video, so go watch that if you're not familiar with them. Essentially, they are a great way to make some objects to store some data. And also, this is the same method that I used to define the building types in my Complete Builder Defender course. So this is an excellent way to define various types. Here,
I'm gonna have to go to watch that. Oh. Gotta love it, right? Let me look. Looks like I'm gonna have to go get it. All right, cool. Scriptable object. I mean, that's a good thing to learn too. Let's see.
we're going to look at scriptable objects in Unity. These are objects you can create in your project files that can be used to store any kind of data and make your game more designer friendly. Extremely useful for storing level data, enemy data, weapon data, and just about anything. We're going to learn how they work, and then later we're going to apply them to systems we made previously, like the crafting system. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so scriptable objects are an excellent feature that makes your game much more designer friendly. Essentially, they are simply containers of data. You define the various fields you want your object to have, then you create instances of that object in your project files and set those fields to whatever you want. The key point is you define and store all that data in discrete objects in your project files, rather than having all of that written directly in the code. If you want to make your game more designer friendly, then scriptable objects are the way to go. Okay, so here we're going to learn the basics on how to define and create scriptable objects, and then later on we're going to take what we learn here and apply it to the crafting system that we made previously. So the items will be defined as scriptable objects, as well as the crafting recipes. This video is made possible thanks to these awesome supporters. Go to patreon.com/unitycodemonkey to get some perks and help keep the videos free for everyone. Alright, so in here, let's make a very simple scriptable object. Now down here in our project files, let's create a new C# script. Call this our test scriptable object. And let's open it. Okay, now here we have our default Unity code. Now the first thing we do is let's get rid of all of these methods. And in here, instead of extending mono behavior, we're going to extend scriptable object. And just like this, we already have a class that we can use as a scriptable object. Now, like I said, they are containers of data, and how you define whatever data you want to store is by defining some fields. So in here, let's define a public string, call it my string. Okay, now we have a scriptable object with a simple string field. Now let's see how we can create an instance of our scriptable object. Now to do that, we go up here to our class definition, and we're going to add the attribute create asset menu. Then we have three optional parameters. So first of all, let's define the file name. So this is going to be the default file name whenever we create an object. So in this case, let's just call it the same name, so test scriptable object. Then we have the menu name. So this is where it will show up on the create asset menu. So in this case, let's create a scriptable objects folder. So you create a folder by simply putting a / at the end. And then let's call it test scriptable object. And lastly, if you want, you can add the order attribute, or it doesn't matter, so let's just ignore that one. Alright, so that's it. Over here we have the most basic scriptable object definition possible. We just extend scriptable object, we define our
What? File name to the create asset menu. Let's throw on a flag. Suppose preview. Bruh, how is he getting away with that? Ah! Use preview languages. Okay. I guess. Take a step back, homie. Oh, I see. Yeah, that changes everything, huh?
Object. And lastly, if you want, you can add the order attribute, or it doesn't matter, so let's just ignore that one. Alright, so that's it. Over here we have the most basic scriptable object definition possible. We just extend scriptable object, we define our fields, and we add the create asset menu attribute. And now if we go back into the editor, now in here on our assets folder, I can right click, go into create, and yep, over here we see scriptable objects, our very nice folder, and inside we can create a test scriptable object. So just click on it, and yep, it starts off with our default name. And for now,
That's
yep,
pretty cool.
Leave it named like that. Alright, so here we have our scriptable object. And we can see all the fields that we defined. So in this case, just a simple string. So in here, let's just write some text. Alright, there it is. And now this scriptable object has been saved with this data. Okay, now let's see how we can use this. Alright, so in here, let's create a new C# script. Call this just testing. Let's create an object to run it. And drag the script. Okay. Now here, let's start off by adding a field for our scriptable object type. So we're going to make it a serialized field so we can set it in the editor. Let's make it a private of type test scriptable object. And then on the private void start, let's simply do a debug log on the test.
That's pretty cool. I did not know that's what that was. Serialized field, private test object. It's not what I wanted.
Test scriptable object, and we access my string. Alright, so there it is, very simple. Now back in the editor, yep, over here we have a field of type test scriptable object. So we can drag our specific scriptable object, yep, and let's try. And yep, over here we can see our very nice message. So we access the scriptable object and grab the data from it. So now to see how this is useful, we can duplicate this scriptable object. So we make a second scriptable object. And over here we give it a different string.
Subscribe to Code Monkey.
Alright, and now go back into our testing script, and then
you should
use the scriptable object instead. And if we run, yep, there you go. Now we have the different message. So we have two different scriptable objects, each with their own instance of data, and then we have our script which works with that scriptable object type. Alright, awesome. So here we can see the most basic usage of scriptable objects. We define our object with whatever fields we want. So here, for example, we have a simple string, but we could add, for example, let's say a public int for an int field. Then we could also, for example, add a sprite array. So we can add whatever fields we want to store whatever data we require. And if we look in the editor and select our scriptable object, yep, there you go. Here we have all of our fields and we can set them to anything. So for example, on this one, I can set 2 elements on this array, and then on this second one, I can select 5 elements. So yep, there you go. Each of them has the same format, but different data. So we can create as many instances of this type of object as we want in order to store whatever data we need. So just like this, you can already imagine the possibilities. So for example, if you have an item, you would have a string for the item name, then you would have a sprite field for the visual, and so on. Another example is if you had a grid system like the one we made previously, you could use a scriptable object to define the size of the grid and all of its attributes. So you can see how they are extremely versatile. Now, one key thing about scriptable objects is the difference between how data persists in the editor or in a build. While you're running in the editor, any changes you make to the scriptable object will be saved on the actual asset. So if you're running the game and you have a scriptable object for the player max health and you change that, the new value will be saved to the asset and will be used the next time that you hit play. However, when playing on a build, the changes are not persistent. So if you modify the scriptable object while playing the build and close and reopen it again, it will go back to the original value. So whatever value you set on the scriptable object when you made the build will always be the starting value when you actually open the game. And since you can edit them and save the changes while working in the editor, another usage for scriptable object is for building editor tools. Now, another important thing about scriptable objects is related to the type of object they are. Scriptable objects work as references. So over here we have our testing script, and we have a field for our scriptable object. So when we set it over here in the editor, what it gets is a reference to the scriptable object instead of a copy of that data. So this has several implications. Now it means that these scriptable objects can help you reduce the memory footprint of your game. So for example, if you have a prefab for each enemy and they contain lots of data in their weapon, if you instantiate that prefab, it will constantly duplicate the data for that weapon. However, if that weapon data is stored as a scriptable object, then in terms of memory, when you instantiate an enemy, it will simply have a reference to the scriptable object. So it ends up with no duplicated memory. When you have a game with lots of enemies and memory issues, this can turn into huge savings. Alright, so again, here we just saw the basics, so this is just one example. Scriptable objects can be used for just about anything. In fact, you've almost certainly used scriptable objects without even knowing it. Like I said, they can be used for building editor tools, and many Unity features and editor tools use scriptable objects to handle their data. So for example, one of the things is the universal render pipeline asset. So this is one example of a scriptable object, and everything here is made with a custom editor. Another example is over here a post-processing profile, which once again all of this data is stored using a scriptable object. So you can see how even without knowing about scriptable objects, you've already used them. So if you're making your own custom tools, you can use scriptable objects combined with custom editors to manage whatever data you need to save. Alright, so that's the basics. Now in the next video we're going to apply what we learned here and modify our previously made inventory and crafting systems to work with scriptable objects. So we're going to create some really nice designer-friendly objects to create each item and each recipe. So go ahead and hit the bell icon to be notified when that video comes out, which should be soon. If you found this video helpful, consider liking and subscribing. This video is made possible thanks to these awesome supporters. Go to patreon.com/unity.
We're gonna have to go back and actually watch that when we get to that part. But for now, well, you know how this works. So let's see. Let's go back to watching this. And unfortunately, I think after watching this video, I'm going to have to go. I know I've done a total of nothing, but dog requires the walk. So let's just get through this.
Script with the definition. As you can see, it's pretty simple, just a handful of fields. Over here we have a name, a transform for the final prefab, a transform for just the visual, then an integer for the width, and another one for the height. Now here we're working on the XZ plane, so really the height is really more of the length, but personally I prefer the word height. Then the other thing we have is also some functions related to direction. We're going to see those in a bit. So essentially we have the scriptable object where we can store our name and our prefab and the width and the height. And here in the editor we've got all various scriptable objects. Again, go watch that other video if you're not familiar with this. So we have multiple building types, and some of them, like for example the town hall, occupies more than one grid position. Here it uses a width and height of 2 by 2. So let's test our current code using this. First, let's refactor our code to work with the scriptable object instead of a transform directly. So here for the serialized field, let's make it of type placed object type scriptable object. And then down here for transform, just go inside that and instantiate the prefab. Okay, so that's it, that's all it takes. Now in the editor, let's select the object, and over here let's drag the town hall reference. Okay, let's test. Okay, so here I am, and if I place it in here, and yep, so far so good, it worked perfectly. And if I try to place on this position again, nope, I cannot build. However, right away on looking at the text, you can see the issue that we have. So you can see that only this value on this grid position was set. So this one on 3.2 is not being occupied by anything, same thing for that one and that one. So if I go ahead and click on this one, yep, there you go, now they are overlapping. So this is the issue that we want to solve. For that, essentially we're going to need to fill in multiple positions on the grid with the same reference. Over here, we instantiate our prefab, alright, then we go into the grid object and set the transform. However, we also need to know what other grid positions will this building occupy. So when working with the building with the size of 2.2, if I click here on 2.1, I want to occupy 2.1, 3.1, 2.2, and 3.2. So what that really means is we start on the origin position, then we're going to fill everything alongside the width, and also everything alongside the height. And here on the scriptable object, I've got a function to do exactly that. Again, for now, we ignore the references to the direction. All that matters is really just this. So this function takes an offset, so that's the base offset, like for example the position where we're clicking on, and then simply cycles through the whole width, cycles through the whole height, and then adds it to the list. So just the offset plus the x and the y. It just does that and then returns a list of vector2 ints. Now we can go back into the grid building system, and here let's call in that function. So we're going to go into the placed object type scriptable object and call in that function to get the grid position list. And now we need to pass in the offset, which is going to be our xz, and this requires a vector2 int, so let's pass in the x and the z. And then for direction, again, right now we're not worrying about it, so let's use the default direction, which is down. We're going to see direction in a bit. Alright, so this returns a list of vector2 ints. So this is the grid position list, so all of the grid positions that this building will occupy. And all we need to do is over here when we set the transform, instead of setting just on one grid object, let's cycle through all of those. So for each vector2 int, for each grid position in the grid position list, for each of those we're going to go into the grid and get the grid object on this grid position, and then we do our set transform. Alright, so now we are setting the transform on all of those, so let's see. Okay, so here I am, and as I click, yep, there you go, now it does fill in all the positions. So if I click here, nope, can't, nope, nope, and nope. Alright, nice. Great. So placing is working. I cannot place any more on any of these positions. However, we still have one issue. If I click over here on the left side and I click, and yep, there you go, now we've got another overlap. So the issue is that right now we're only testing if we can build on the clickable position. The answer is we need to apply the exact same logic that we just saw. We need to test if we can build, not just on where we click, but on all the positions that will be occupied by the new building. So over here we got the grid position list, we just need to call can build on every single one of those. Alright, so here's the logic. So we just go through every grid position on the grid position list, alright, and then we test for every single one of them if we can build, and if there's just a single one that we cannot build, then we set this can build boolean into false, we break out of the cycle, and then down here, either it passed all of them or it didn't pass at least one of them. So if we test, so over here, let's build in here, alright, and if I click here, 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 or here, nope, alright, everything works. And now if I click here, and nope, cannot do it. If I click here, can't do it, and can't do it.
Nice.
But if I go here and click, yep, now it does work. Alright, awesome. So we now have the ability to place down buildings with different sizes. Now next, let's handle rotation. For that, let's test with the gas station, which has a width of 2 and height of 1. So here, if I place the gas station, yep, there you go, it's like that. So let's rotate this one. As we saw previously on the scriptable object, I already defined an enum for the direction, so just down, left, up, and right. Now in the grid building system, let's store the current direction. So let's go into the placed object type.
Looks like I planned poorly again.
Direction, so the
first day coming back.
And
that's how things go. I took my dog out this morning. She did her business, but apparently she needs to go again. So sorry guys. Yeah, so far it looks like if you're going to do this, video, make sure you check out the other two. I will post them on my Twitter account there. So I'll do an update on there. But you're going to want to check out, let's see. So, okay, so far we're breaking for today as doggos require wacko. But what we learned for this segment is you should be familiar with the following videos for ahead of time. Let's see, we're gonna put, we need the simple game one. Pause it. not that one. Oops. Modify, transform, pivots. So you need this one. Pivot. Object, transform, pivot. And also you'll need the know about scriptable objects. Legit. All right, guys. Sorry for the short stream, but hopefully tomorrow what I'll do is maybe I'll try to, well, I mean, technically it's roughly an hour, but I'll try to get my dogs to go out beforehand and do their whole business. Before I stream, get a solid hour in, and yeah, that way I can get in and do this and then actually get to work. But thanks for tuning in. I hope this at least helped you realize you got to go through a few things before we get to the awesome grid building part. So